Thank you. It's just a great pleasure to be here on behalf of Synopsys. So as Callista said, my name is John Koeter. I'm a Senior Vice President of Product Management at Synopsys, and I'm here to tell you how Synopsys and RISC-V are working together to really bring unique and innovative opportunities here to you as you're designing chips and you're designing systems. All right, so now change is happening across many industries, and I'm just going to give you a few stats here. Did you know the amount of compute power is doubling every 100 days? Did you know that there are 1.8 billion gamers in the world? Do you know that AR/VR hardware is supposed to be 15 billion by 2017? Do you know that by 2030 there's supposed to be 300 million lines of code in an automotive? There is just gigantic changes, and semiconductors are at the heart of all of these changes. Just really, truly monumental changes going on in the industry. I'll have one more do you know stat. Did you know that it took 60 years for the semiconductor industry to go from 0 to 500 billion? The forecast is by the end of the decade, in 6 short years, the semiconductor industry will double again. It'll double. It'll be $1 trillion industry. And that's just absolutely amazing. You know, semiconductors are at the heart of that revolution, but certainly software is driving the differentiation. It's software-driven vehicles. Wherever you look, wherever you turn, you know, having hardware optimized for the software workloads is just absolutely critical. And so with all this, we need to be productive, and we need to be efficient. We need to embrace open standards, and we need to drive to unleash that next wave of innovation. So I'm going to talk about some momentum that we're seeing in RISC-V. And you know, RISC-V has been going on for many years now. And I just want to focus on the last 6 months, just 6 months. The progress has been amazing, you know, whether it's some leaders in here like Tenstorrent or, you know, Star5 getting funding milestones, whether it's companies like Meta and Qualcomm announcing, you know, key initiatives around RISC-V, whether it's the Linux Foundation and RISE, you know, creating more open source software, or whether it's a German JV with Infineon and Nordic and NXP and Bosch and Qualcomm all coming together to drive RISC-V into automotive. Just a really exciting time. Just a few more stats here. 4,000 RISC-V members. That's amazing. That's up 25% basically in 1 year. Callista was telling me that the registrations were up about a similar amount. Actually, I think even higher, she said, just this year. 111 chip companies have announced that they are doing RISC-V processors. 55 software companies are jumping on the bandwagon here, creating software for RISC-V, and more than 12 different industries are represented. I'll also call your attention to the graph. Today, the amount of CPUs shipping, number of SoCs containing CPUs, I should say, is around 30 billion. That's anticipated to go north of 50 billion in the next few years. And you know, as so much heterogeneous compute is being targeted across all these different industries, we really see the configurability and the expandability and the flexibility and the ecosystem of RISC-V generating a lot of momentum for the ISA and for people providing solutions based around it. All right, so I just wanted to, you know, close out this particular section with 2 additional quotes. So Semico, a well-known research firm, is saying that in automotive, it'll be a little under $1 billion in 2027. And Omdia is saying that 30% of all IoT devices will be based on RISC-V by 2028. These are just amazing stats. But you know what? We like to show this picture of the iceberg here because, you know, the ISA is the tip of the iceberg. What it really takes to have a successful processor implementation is a wide variety of other factors. You have to implement the ISA extremely efficiently. You have to have best-in-class software tool sets. You have to think about your simulators. You have to think about your prototyping models. You have to think about your test. You have to think about cybersecurity. You have to think about FUSA certification. There is many aspects that go into producing high-quality RISC-V processors above and beyond the open source ISA. So today, just today, we announced a new family within our ARC product family. We call it, cleverly, ARC-V, right? And this is an evolution of our ARC processors to include the RISC-V ISA in them. Now, we're announcing today 3 separate product families. The RMX series. The RMX series is a 32-bit and deeply embedded processor, a 3 or 5-stage pipeline. It has optional DSP extensions, and it has a full FUSA hybrid mode for this. So that's the ARC RMS, really targeted on deeply embedded applications, very power, very area efficient. Now let's move on to the middle section, which is the ARC-V RHX series. And here, this is still a 32-bit CPU family, but now it has a 10-stage pipeline. It's focused on real-time applications. For the first time ever in the ARC product family, it has hardware virtualization support, and you can cascade these to have up to 16 different cores. And in addition to this, we have hardware accelerators that we can use to give you even more performance, and I'll talk more about those in just a minute. So that is the ARC-V RHX family. The last member in the family is called the ARC-V RPX series. Now, the ARC-V RPX series is a full 64-bit multi-core host processor that's supporting user and supervisory modes. It offers cache coherency. It will run Linux applications. It interfaces to common NOCs like the AMBA CHI interface. And so this is a true 64-bit processor that's really targeted at host applications. You know, so some might say, well, Synopsys, are you going after the data center? Are you going after the mobile phone processors with this new ARC-V family? And the answer is no. I mean, but there are plenty of applications that need a very power and area efficient host processor, which is also configurable and also extendable, which is really kind of at the heart of the entire ARC family philosophy. For those of you who don't know, by the way, we acquired ARC-V, we acquired ARC, I should say, back in 2011 when we acquired Virage Logic. And actually, ARC as an ISA has been around for 25 years. So this is something that, again, it's a very natural evolution of where we're going, you know, as the second largest IP company on the planet. So I also wanted to say that in addition to these 3 new product families, of course we'll be continuing to support our existing ARC families. You know, these processors stay in applications for, you know, sometimes decades, really. But there's 2 other family members within ARC, and that is the ARC NPX, which is a neural processor accelerator. I like to call it AI at the edge. Very good for things like object detection and that kind of thing. We also have a DSP, which we call the VPX product line, which is a DSP that was built from the ground up, not for the traditional DSP applications of audio, but designed from the ground up for data-intensive applications such as LiDAR and radar. So we have a broad portfolio of processors here within the overall umbrella of ARC. In addition to the processor family, we also have a tool that we call ASIP Designer that allows you to roll your own processor. So in ASIP Designer, you describe the functionality of the processor that you want in a high-level programming language, and then the tool produces both the RTL for the processor as well as a tool chain. And we have many, many customers who are using this. In fact, I think 50% of the usage for ASIP Designer is actually for designing custom RISC-V cores. And we provide various templates that you can use to jumpstart and create your own highly efficient RISC-V cores if you'd like. All right. So, you know, I remember that old phrase about, you know, hey, it's the software, right? And it really is about the software. The hardware is great and it's important and it's optimized for area and power and performance, but it's also about the software tool chain. And I think one of the advantages that Synopsys brings here as we get into RISC-V is that we bring a very proven software tool chain, the Metaware tool chain. The Metaware tool chain is actually even older than ARC, believe it or not. It's 40 years. Just hit its 40th birthday this year here. And so this is a world-class, state-of-the-art development system with, of course, an IDE, with the runtime libraries, with the advanced debuggers, with cycle-based simulators, functional simulators, optimizing compilers, Simulink models, and all of it, the entire tool flow is also FUSA certified. Now, we're also, as I mentioned, there are a new standard called ISO 21434, which is cybersecurity. Maybe some of you have heard of it. But you know, our customers are really demanding that, particularly in automotive, but also in many other different types of applications. And so our ARC-V processors and the tool chain will all be certified against the 21434 standard, as well as, you know, FUSA certifications and ASIL-D certifications. Okay. So now let me talk about the broader Synopsys, and you know, we have solutions for RISC-V across all of Synopsys. So for example, we have these things called quick kits, which are Fusion Quick Start kits. And these enable you to get out of the box and get great PPA from your RISC-V core. Because we're working with all the RISC-V vendors, not just ARC-V, but we're working with Sci-Fi and Andes and others to provide highly optimized implementation design flows. And these are, of course, process specific, and they're tunable down to 2 nanometer. I also want to highlight the tools that we have for early architectural exploration and software development. So we have a tool called Platform Architect that allows you to model the workloads and make an efficient implementation in your architecture, your choices, to have the right and the best architecture. Along with that, we also have a tool called Virtualizer, which enables you to run software on a TLM version, a transaction level modeling version of your core. And so we're working with, again, the entire ecosystem for RISC-V to enable that. You know, these days, nobody's going to push the button to tape out any SoC without running the software on it. That's a given, because pushing that button is unbelievably expensive, especially as you go to advanced process nodes. And Synopsys has the highest capacity and fastest hardware-assisted software verification platforms. And specifically here, I'm talking about ZeBu, and I'm talking about HAPS. And last but not least, we also have a very broad portfolio of IP that is optimized for use with RISC-V ISAs and processors like R5. So what do I mean by that? I mean interface IP like USB and Ethernet and high-speed Ethernet, die-to-die, you know, those kind of things. I mean security processors, hardware root of trust as an example, or crypto cores. I mean, things like foundation IP, memories, and standard cells. So we have OTP as another one. We have a very broad portfolio of IP that we will be optimizing and working with not just our own cores, but all the cores in the industry to put forth the very best solution possible to enable the RISC-V ecosystem. I'd like to call your attention to two quotes that were part of our press release today. The first is from Thomas Baum, who is the Senior Vice President at Infineon. And he says, I'll read this to you. He says, by developing safety-certified RISC-V-based processor IP, Synopsys is supporting us to expand the architecture to build high-performance automotive systems with the highest level of functional safety. I also like to call out the quote here from Dan Mender at Green Hills, where Dan is saying, Green Hills is pleased to extend our production-focused family of safety-certified operating systems, compilers, and development tools to support Synopsys' new RISC-V-based ARC-V processor IP. So if I wrap this all up here today, it's really our great pleasure to be here and talk to you about how bright we think the future of RISC-V is and how we, Synopsys, are standing behind RISC-V to make it successful in the industry across our whole portfolio of IP and tools and solutions here. Because you know what? SoC designers are looking for open source solutions for collaboration and flexibility. You saw the growth curves in the adoption of RISC-V, and you saw the incredible monumental changes that are happening in all of these market segments. And so we, Synopsys, are going to be there. We're going to be there to help you enable your next wave of SoC innovation based on the RISC-V ISA. And I'm also happy to announce that you can go have a drink on Synopsys. We're sponsoring the reception here. So please visit us in the exhibit hall and then also have a drink with us later. Myself and other colleagues from Synopsys will be all around the exhibit hall, and we look forward to answering any questions that you might have about how we're continuing to move forward the RISC-V ecosystem along with all the partners and the customers here in the room. So thank you very much.